In this lesson, we are going to talk about roots and radicals. We begin with the definition of square root. R is a square root of a if r squared is a. For example, 2 and negative 2 are both square roots of 4 because 2 to the power of 2 is 4, negative 2 to the power of 2 is also 4. So 2 and negative 2 are square roots of 4. 3 and negative 3 are square roots of 9 because 3 to the power of 2 is 9 and negative 3 to the power of 2 is also 9. 0 is a square root of 0 because 0 to the power of 2 is 0. As you can see, only non-negative numbers, 0 is not negative, 4 is not negative, 9 is not negative, and generally only non-negative numbers have square roots. So negative numbers have no square roots. For example, what is a square root of negative 4? So can you think of any number such that I raise that number to power of 2 and it gives me negative 4? Such number does not exist. There is no number so that I can raise it to power of 2 and get negative 4 as a result. So the square root of negative 4 does not exist. And another thing that you should notice here is that all positive numbers have two square roots, one positive and one negative. 0 is not a positive number, it has only one square root. 9 is a positive number and it has two square roots, one positive and one negative. 4 is a positive number and it has two square roots, one positive and one negative. And this is true about all the positive numbers. All the positive numbers have two square roots, one positive and one negative. So assume that a is a positive number, and this notation, we can read that as radical a, is the notation we use to represent the positive square root of a. So this is the positive square root of a. And for the negative one, this is the notation that we use, negative radical a. This is the negative square root of a. So this is the radical notation. Assuming that a is a positive number, radical a is the positive square root of a, and negative radical a is the negative square root of a. And if a is negative, then radical a is not defined. For example, negative 4 is a negative number, radical negative 4 is not defined. But for example, 4 is a positive number, radical 4 is 2, that's the positive square root of 4, and negative radical 4 is negative 2, which is the negative square root of 4. So according to this definition, radical 5 is the positive square root of 5, which is about 2.236. As you can see, I say it's about 2. If you use your calculator, radical 5 is about 2.236. But this number, radical 5, you can never write it as a decimal number. As you can see here, I have just an approximation of that. So if you have a very, very good calculator, you can calculate this up to probably 8, 10, 20 digits after the decimal point, but it never ends. It's an irrational number. Since this number can never be represented as a decimal number, we have to choose this symbol, radical 5, in order to represent it. Okay, another remark that I need to mention about the square root is that so radical 5 is the positive square root of 5, and negative radical 5, which is negative 2.236, approximately negative 2.236, is the negative square root of 5. Another thing I need to mention is the square root of a squared. Square root of a squared is absolute value of a. What does this mean? Absolute value of a is a if a is greater than or equal to 0, and it is negative a if a is less than 0. So for example, absolute radical 5 to the power of 2 is absolute value of 5, and since 5 is a positive number, absolute value of 5 is just 5. But radical negative 5 to the power of 2 is absolute value of negative 5, and since negative 5 is a negative number, absolute value of negative 5 is negative 5. So it's negative 5, which is again 5. So this formula assures that the square root of any number is always something positive, because according to the definition, a radical a squared is the positive square root of a squared. Okay, now let's go on to the cube root. R is a cube root of a if r to the power of 3 is a. So that's the definition of cube root. R is a cube root of a if r to the power of 3 is a. For example, 2 is a cube root of 8. That is because 2 to the power of 3 is 8. Negative 2 is a cube root of negative 8. That is because negative 2 to the power of 3 is negative 8. 0 is a cube root of 0 because 0 to the power of 3 is 0. As you can see, all numbers, all real numbers have unique cube roots. And this is the notation, this is the symbol we use to represent the cube root of a. So this is radical index 3 of a. So this number here is called the index of the radical, and if the index is absent, it is implied, it is understood to be 2. So just radical a is the square root of a, but when you have the index 3, it would be the cube root of a. So this is the cube root of a. So for example, radical index 3 of 8 is 2. That is because 2 to the power of 3 is 8. And radical index 3 of negative 8 is negative 2. That is because negative 2 to the power of 3 is negative 8. Uh, Radical index 3 of 5 is the cube root of 5, which is almost 1.71. This is also an irrational number. You cannot represent it precisely as a decimal number. That's why we need this symbol to represent the cube root of 5. Notice that radical index 3 of a to power of 3 is just a. So for example, radical index 3 of 2 to power of 3 is just 2. Radical index 3 of negative 2 to power of 3 is just negative 2. Okay, now let's move on to a general definition of the nth root of a number. R is an nth root of a if r to power of n is a. For example, 2 and negative 2 are fourth roots of 16. That is because 2 to power of 4 is 16. Negative 2 to power of 4 is also 16. 3 is a fifth root of 243. That is because 3 to power of 5 is 243. Okay. As you can see from previous examples, only non-negative numbers have even roots. So, for example, negative 10 does not have any even roots. Radical negative 10 does not exist. Radical index 4 of negative 10 does not exist. Radical index 6 of negative 10 does not exist. Radical index 8 of negative 10 does not exist. None of these exist. That is because only non-negative numbers have even roots. And all the positive numbers have two even roots. For example, 16 has two fourth roots. 2 is a fourth root of 16. Negative 2 is a fourth root of 16. So, if n, the index, is even, then radical index n of a is the positive nth root of a. The positive nth root of a. And negative radical index n of a is the negative nth root of a. And for all the even indices, radical index n of a to power of n equals absolute value of a. For example, radical 3 to power of 4 index 4 is absolute value of 3, which equals 3. Or radical negative 3 to power of 4 index 4 equals absolute value of negative 3, which is again 3. So this is true about the square root, and this is true about any even index. So I repeat, only non-negative numbers have even roots, and all the positive numbers have 2 even roots. For example, all the positive numbers have 2 fourth roots. This is the symbol we use to represent the positive nth root of a. This is the symbol that we use to represent the negative nth root of a, where a is something positive and n is something even. Now, just like the cube root, which is an odd index, all real numbers have unique odd roots. So if n is odd, then radical a index n is the unique nth root of a. For example, radical index 5 of 243 is 3. That is because 3 to the power of 5 is 243. And if a is any real number and n is something odd, radical n a to the power of n is just a. So, for example, radical 5 negative 8 to the power of 5 is just negative 8. Okay, there is another notation that we sometimes use in order to represent the nth root of a. And that notation is a to the power of 1 over n. So this is another notation that we use to represent the nth root of a. So this also is the same as radical a index n. Obviously, a to the power of 1 over n is the nth root of a, because if we have a to the power of 1 over n and we raise that to the power of n, what we get is a to the power of n over n. We have to multiply these two, which equals a to the power of 1, which equals a. So you can see that a to the power of 1 over n is the nth root of a, because if I raise that to the power of n, I get a. So don't forget that these two are the same concept. Both of them represent the nth root of a. We also have this one, a to the power of m over n is a to the power of 1 over n, this whole thing to the power of m. So this we know is radical index n, of a. So this is radical index n of a raised to power of m. A to power of m over n can also be written as a to power of m, this whole thing raised to power of 1 over n. So this would be radical index n of a to power of m. So as you can see, a to power of m over n is equal radical index n a to power of m, which is also equal radical a index n to power of m. Okay, let me give you an example. 4 to power of 3 over 2. 4 to power of 3 over 2, according to this formula, is radical index 2. I don't need to write that, it is implied, of 4 to power of 3. Okay, let me write that for clarification. So it's radical index 2 of 4 to the power of 3, which is radical 64, which is 8. Okay, there are a number of radical rules that we're going to use while we're simplifying radical expressions. Okay, the first one is a radical index n of a times radical index n of b is radical index n of ab. This one is equivalent to a to power of 1 over n. So I'm writing the same formula using the rational exponent notation. Radical a index n is a to the power of 1 over n, and radical b index n is b to the power of 1 over n. And from the exponent rules, we know that if we have the same power and different bases, we can just multiply the bases using the same power. Yes? So as you can see, these two rules are actually equivalent. Radical index n of a over b is radical a index n over radical b index n. This is actually equivalent to the exponent rule that says a over b raised to the power of 1 over n is a to the power of 1 over n over b to the power of 1 over n. And we also have this one, radical a index n is equal radical a to the power of m index nm. This is equivalent to a to the power of 1 over n is equal a to the power of m over nm, which is obviously true because I can cancel the m from the numerator and from the denominator, and I get a to the power of 1 over n. Okay, let's look at some examples. For example, radical 2 times radical 8. This is radical 16, which is 4. I can simplify radical 12 like this. Radical 12 is radical 4 times radical 3, but radical 4 is 2, so this is 2 radical 3. When I'm doing this simplification, what I do is that I notice that this is a radical of index 2. So I ask myself, how can I decompose 12, factor 12, and write it as the product of a perfect square and another number? I can write 12 as 2 times 6, but none of them are perfect squares. 2 is not a perfect square and 6 is not a perfect square. But if I write 12 as 4 times 3, then since 4 is a perfect square, I can write 2 for radical 4, and I am simplifying the expression. So that's what I'm doing here. I'm asking myself, how can I write 12 as the product of a perfect square and another number? And the answer would be 4 times 3. Another example, 14 over radical 14 over radical 7. This is radical 14 over 7, which is radical 2. Radical 50. Okay, again, I ask myself, how can I write 50 as the product of a perfect square and another number? Why perfect square? Because I have an index of 2. And the answer is 25 times 2. So this is radical 25 times radical 2, which is 5 radical 2. Radical 2. Okay, now how do we add up radical expressions? How do we subtract radical expressions? Let's take a look at some examples. We have radical 27 plus 3 radical 2 plus radical 12 minus 2 radical 18, and we want to simplify this expression. Okay, I can see that 3 radical 2 is in a simplified form, but 27 can be written as 9 times 3, and 9 is a perfect square. So that's what I'm going to do. I'm going to write 9 times 3 plus 3 radical 2, I just carry that. 12 can be written as 4 times 3. Why 4 times 3? Because 4 is a perfect square. Why 9 times 3? Because 9 is a perfect square. Minus 2. Radical 18 can be written as, for example, 3 times 8. 3 times 6, but that doesn't help me because 3 is not a perfect square, 6 is not a perfect square, so I'm not going to write 18 as 3 times 6. 18 can also be written as 9 times 2, and that is the one that I can use because 9 is a perfect square, so I'm going to write that as 9 times 2. Okay, now this is radical 9 times radical 3 plus 3 times radical 2 plus radical 4 times radical 3 minus 2 radical 9 times radical 2. Radical 9 is 3, radical 3 plus 3 radical 2 plus radical 4 is 2 radical 3 minus radical 9 is 3. 3 times 2 is 6, so minus 6 radical 2. Okay, now, how do we proceed? Here, you can just add up the like terms. Here, the like terms are those terms that, or those radicals that have the same index and that have the same radicand. So, I have 3 radical 3 here, and I have 2 radical 3 here. 3 radical 3 plus 2 radical 3 is 5 radical 3. and I have 3 radical 2 here, and I have minus 6 radical 2 here. I just add up the coefficients. 3 minus 6 is minus 3. So it's minus 3 radical 2. Radical 3 minus 3 radical 2. Let's take a look at another example. Three plus radical 6 times 2 minus radical 6. Okay, I'm going to multiply these two radical expressions and simplify. So I need to do 3 times 2 plus 3 times negative radical 6 plus radical 6 times 2 plus radical 6 times negative radical 6. 3 times 2 gives me 6. Okay, let me write it like all the steps. 3 times 2 minus 3 times radical 6 plus 2 times radical 6 minus radical 6 times radical 6. Now this is 6 minus 3 radical 6 plus 2 radical 6. These are like terms. Minus 3 and 2, I need to add them up. It gives me minus radical 6. And then here I have minus radical 6 times radical 6. Radical 6 times radical 6 is radical 36, and radical 36 is just 6. So this is minus 6. Now this cancels this, and I'm left with minus radical 6. Generally, radical a times radical a is a. So for example, what is radical 7 times radical 7? Just 7. Why? Because radical 7 times radical 7 is radical 49, which is 7. When you're simplifying fractions that contain radicals, sometimes you're asked to rationalize the denominator. Rationalizing the denominator means getting rid of the radical expressions in the denominator of a fraction. And when you're rationalizing the denominator, you're using these two formulas. Radical a times radical a is a, and the other formula that you're using is a plus b times a minus b is a squared minus b squared. Now let's see how we use them. If you're supposed to rationalize the denominator of this fraction, what you need to do is you need to get rid of the radical in the denominator without changing the value of the fraction. So what you're supposed to do is to multiply both numerator and denominator by radical 5. Then you would have 2 radical 5 in the numerator, and you would have just 5 in the denominator, because radical 5 times radical 5 is 5. And now you have rationalized the denominator. So generally, if you have a over radical b, you just multiply both numerator and denominator by radical b, and you get a radical b over b, and you have rationalized the denominator. Another example, if you have 8 over radical 11 minus 3, and you want to rationalize the denominator. Here you have a minus b in the denominator. So radical 11 is my a and 3 is my b. You have a minus b in the denominator. What you need to do is to multiply both numerator and denominator by a plus b, which is radical 11 plus 3. radical 11 plus 3. Why do you do that? Because if you multiply both numerator and denominator by the conjugate of the denominator, you can rationalize the denominator. Let's see how. So you get 8 times radical 11 plus 3. But in the denominator, if you use this formula, you had a minus b. You multiplied by a plus b. Now you can use this formula and you get radical 11 squared minus radical minus 3 squared. So you get radical 11 squared minus 3 squared. So this is 8 times radical 11 plus 3 over radical 11 squared is just 11 minus 3 squared is 9. So now you have 8 times radical 11 plus 3 over 2. 2 and 8 simplify. So you get 4 times radical 11 plus 3, and now you have rationalized the denominator. So generally, if you have a minus b, you multiply by a plus b, and if you have a plus b, you multiply by a minus b, so that you can use this formula. These two are actually called the conjugates of each other. Okay, let's take a look at another example where you have a plus b in the denominator. Radical 5 minus radical 3 over radical 5 plus radical 3. Okay, here you have the form a plus b in the denominator, so you multiply both numerator and denominator by the conjugate of the denominator, which is radical 5 minus radical 3, which gives you radical 5 to the power of 2, which is 5, minus radical 3 to the power of 2, which is 3. As you can see, you have rationalized the denominator. And the numerator, if I multiply radical 5 times radical 5, is just 5. Radical 5 times negative radical 3 is negative radical 15. Negative radical 3 times radical 5 is also negative radical 15. And minus minus is plus. Radical 3 times radical 3 is 3, so plus 3. So you get 8 plus minus 2 radical 15 over 2. Now if I factor out a 2 from the numerator, I have 4 minus radical 15 over 2. The 2 cancels the 2, and I'm left with 4 minus radical 15. Okay, some more examples. How do we simplify this expression? Negative 3 to the power of 5 over 3 times negative 3 to the power of 4 over 3. We have to use the exponent rules. We have the same base, so we use that and we add up the exponents. That gives me negative 3 to the power of 9 over 3. 9 over 3 is 3. Negative 3 to the power of 3 is negative 27. Another example. 8 x to the power of 9 y to the power of 6, the whole thing to the power of 1 over 3. So this is 8 to the power of 1 over 3. times x to power of 9 to power of 1 over 3 times y to power of 6 to power of 1 over 3. This is radical index 3 of 8 times x to power of 9 times 1 over 3, which is 3, times y to power of 6 times 1 over 3. 6 times 1 over 3 is just 6 over 3 or 2. So the answer is 2x to power of 3 y to power of 2. Two to power of 3 over 2 minus radical 50, and you want to simplify this. Okay, first you need to write this as a radical expression using radical notation. This is radical index 2 of 2 to power of 3 minus radical 50. So this is radical 8 minus radical 50. Now, can I write 8 as the product of a perfect square and another number? Yes, I can write 8 as 4 times 2. Can I write 50 as the product of a perfect square and another number? Yes, I can write that as 25 times 2. So this is radical 4 times radical 2 minus radical 25 times radical 2. Radical 4 is 2, so it's 2 radical 2 minus radical 25 is 5 radical 2. And 2 minus 5 is minus 3 radical 2. Okay, let's simplify this one. 3 plus radical 6 over 5 radical 3 minus 2 radical 12 minus radical 32 plus radical 50. Okay, first of all, I am going to try to write everything that I have in the denominator in the form of radical 3 or radical 2. 5 radical 3 stays as it is. 12 is 4 times 3. 12 is 4 times 3. So I'm going to write that as minus 2 times radical 4 times radical 3. 32 is 16 times 2. So I'm going to write that as radical 16 times radical 2. And 50 is radical 25 times radical 2. So this equals 3 plus radical 6, 5 times radical 3. Radical 4 is 2, 2 times 2, 4, minus 4 times radical 3. Radical 16 is 4, so minus 4 times radical 2. And radical 25 is 5, so plus radical plus 5 radical 2. Okay, now let's add up the like terms. 3 plus radical 6. I have 5 radical 3 and I have 4 radical 3. That gives negative 4 radical 3. That gives me just 1 radical 3. And I have 4 radical 2 and I have 5 radical 2. Negative 4 radical 2 and 5 radical 2. If I add up the coefficients, I get plus radical 2. I'm not done yet because I need to rationalize the denominator. That is part of the simplifying process. So I need to multiply both numerator and denominator by the conjugate of the denominator. And the conjugate of the denominator is radical 3 minus radical 2. Radical 3 minus radical 2. So in the denominator, this gives me radical 3 to the power of 2 minus radical 2 to the power of 2, which is 3 minus 2. In the numerator, I have 3 times radical 3 minus 3 times radical 2 plus radical 6 times radical 3 is radical 18. Radical 18 can be written as radical 9 times 2, so it's 3 radical 2. And radical 6 times negative radical 2, that would be radical 12 minus radical 12, which can be written as minus 2 radical 3. Okay. The denominator is just 1 now. I can add up the like terms. What do I get here? Radical 3 minus 2 radical 3 is just 1 radical 3. And I have a 3 radical 3 here and a minus 3 radical 3 here, which cancel each other. And I am left with just radical 3, which is my final answer. Okay, and that's it for roots and radicals.